Hello guys, welcome back to lecture series on numerical methods. Already I have explained some of the videos in my channel based on the numerical method guys. So if you are interested to see this video, go and check in my playlist. You will get the playlist in my description box over here, or you can check here in I button. Okay. So without further ado, let's get dive into our today's lecture. I'm going to explain to you all the example. So we are going to solve this example using bisection method already I explained in my last lecture. If you are interested to see, go and check this my videos. Okay, a repeated question in SPPU question paper guys. Okay, let me explain the method bisection. Okay, so this one is important for your END-SEM exam. Okay, now see that what we have given, equation given. Okay, let me write the given data first. X cube minus x minus 1 which is equal to 0. This one is the equation given. We consider this one as a f of x which is equal to this equation. Okay, that means y which is equal to this means we write f of x which is equal to x cube minus x minus 1. Okay, this one is our f of x. Okay, this one is our f of x, and the root lies between interval 1 and 2. Okay, and root lies between 1 and 2. Root lies between 1 and 2. Okay, that means we have to put x as 1 and x as a 2. So f of 1 which is equal to, that means x which is equal to 1 and 2. Okay, we have the two value for x which is 1 and which is a 2. Okay, so if root lies between these two values, obviously one of the value between the 1 and 2, we get the solution here for f of x. So we don't know the actual value. Okay, so we have the interval 1 here, another value 2 over here. Okay, one value here and another end of the value here. Okay, so that means the root of this polynomial equation which lies between 1 and 2 over here. Okay, it cannot go smaller than 1 or bigger than 2 obviously, and fixed the value between 1 and 2 lies here. So if 1 and 2 is the root, 1 and 2 is the root, obviously that can give us f of x 0, but this is not the root, but the between of these two values we have root. Okay, yes. So what I'm going to do, I'm going to replace 1 in our f of x, after that 2 in our f of x. Okay, so 1 in f of x means 1 into x, 1 x which is equal to 1 means x1 here, that means 1 cube minus 1 minus 1. Done guys, I replace x as 1. So 1 cube here, minus 1 here, minus 1 here. So 1 cube is a 1, minus 1 which is 0, which gives us the minus 1 value. Okay, so f of 1 is a minus 1. This implies f of 1 is a smaller than 0. What we have, f of 1 is a smaller than 0. But the condition for our bisection, it says that if one of the value for our interval gives a smaller than 0 and another value gives the value bigger than 0 for our f of x, so obviously these are the two end interval, okay, which can give us the solution between that value. Okay, yes. So what we do now, we go for replacement of 2. So f of 2 we write 2 cube. Okay, f of 2 is a 2 cube minus 2 minus 1. Okay, f of 2 is a 2 cube minus 2 minus 1. So 2 cube means 8 minus 2 minus 1. So 8 minus 3 which is a 5. Okay, so f of 2 which is equal to 5. And this implies f of 2 is bigger than 0. Okay, f of 2 is bigger than 0. This means that the value, so roots for our given equation which lies between smaller than f0 and bigger than f0. Okay, that means the root lies between 1 and 2. Okay, but we don't know which is the root, so consider that root as a x1. I consider that one is the x1 is the root for our function that lies between interval 1 and 2. Okay, between interval 1 and 2. Now what we do, we go for applying bisection method. Bisection method says that for first approximation x1 which is equal to, add these two endpoints, 1 plus 2 divided by 2. Okay, 1 plus 2 divided by 2. That means a plus b divided by b is the our first approximation. Okay, yes. So 1 plus 2 divided by 2, this means 3 by 2. 3 by 2 means 1.5. Okay, 3 by 2 means we got the 1.5 as the mid value for our interval 1 and 2. Okay, so we are going to replace 1.5 into our equation in our f of x. Okay, so we have function f of x as x cube minus x minus 1. So x has 1, x1 has 1.5. So replace f of 1.5. Okay, replace f of 1.5. So it gives us the f of 1.5, which is equal to 1.5 bracket cube minus 1.5 minus 1. Okay, use calci guys and find out the answer. Okay, as you all have allowed calci in your exam, so you can use the calci directly. Okay, so that we get the answer f of 1.5. Okay, f of 1.5. I already found this answer, so I'm writing this directly. Okay, so f of 1.5 is 0.875, which is a bigger than 0. Okay, that means f of 1.5 which is having positive value. Now we already we are knowing one thing, that the root lies between positive and negative value. Okay, so if this one is a positive f of 1.5, so we have to find it out which the function has negative value for a particular point. Okay, f of 2 gives us the 5, which is a positive value, but this one is also positive, so we cannot take this value with this one. Okay, if this one is a positive, we have to take the negative. Okay, so negative value we have here, f of 1 is a minus 1. That means we have the interval which is f of 1 which is equal to minus 1, and f of 1.5 is a 0.875. Okay, so this is a negative value and this is a positive value. Always remember guys, the root lies between positive and negative value. Okay, the root lies between positive value and negative value. So this one is a positive value, this one is a negative value, so obviously root lies between one of it, one of the interval. Okay, so now see that this is the root, start from minus 1, start from the plus 1. Okay, start from this is the value for function x is a 1 and the x is a 1.5. So I contracted the interval from 1 to 2 to the 1 to 1.5. Okay, now see that there is a possible chances that possible means there definitely chances that the root lies between 1 and 1.5. Okay, but it cannot give the sure guarantee that which is the root between this interval. Okay, that means we have infinitely many values, so we cannot say which is the specific value. So we have to contract or we have to reduce this interval, okay, to some specific point, so we can easily say that. Okay, now see that we have this interval, repeat the next iteration. Okay, repeat the next iteration. So this one is the second iteration. Okay, this one is the second iteration. So in our second iteration, what we do, we add both of them. Okay, so consider that we have third point here. Consider x2 which is lies between this interval, and this is the solution for f of x. Okay, yes, so we write x2 is a 1 plus 1.5 divided by 2. That means a plus b divided by 2. Okay, 1 plus 1.5, that means 2.5 by 2. Okay, that means if we go for dividation 2.5 divided by 2, we get the 1.25. This is 1.25. Now we have to replace this value to our f of x. Okay, and we know that f of x we have here. Okay, what is the f of x value? Which is x cube minus x minus 1. X cube minus x minus 1. So f of 1.25 is a 1.25 cube minus 1.25 minus 1. This one is the value for 1.25. Okay, yes. So find out the cube, subtract from here and subtract from here. Okay, so you will get the value for f of 1.25 as after subtraction, guys. Okay, after subtraction you will get the value for f of 1.25 as minus 0.2968, minus 0.2968, which gives us the negative value, Now see that this one gives us the negative value, so we want the another positive value, function value. So we can say that this negative and the positive value lies between them. Okay, yes. So this one is a negative value, so we have to consider for this interval only. Okay, between interval 1 and 1.5. Okay, so f of 1 is a negative value, negative of 1, but already we have the negative value f of 1.25. so this negative value cannot match with this negative value, because we want one positive value and another negative value, so that we can say that the solution lies between that negative and positive value. Okay, but we can say here f of 1.5 is a 0.875. This one is a positive value and this one is a negative value. So we can say that the root or the solution lies between 1.5 and 1.25. Okay, now see that we reduce this interval again. Here we have the root which lies between 1.5 and 1.25. Okay, yes. So we have the two value 1.25 and 1.5. 1.5 means we consider 1.50 as 1.5 and 1.50 both are similar. Okay, because as we have 1.25, so up to 2 decimal, so I converted this one to the 2 decimal. Okay, so don't get confused guys. If nothing is there, then you have to put the 0. Okay, so root lies between 1.25 to 1.5. 1.5 means 1.50. So there is another value that lies between these two interval. Okay, so we consider here up to the value of x2. Okay, up to the value of x2, we want the next x3. Consider this is the x3 root which lies between these two values. Okay, so x3 can be written as 1.25 plus 1.50 divided by 2. Add 2 of them, you will get the x3 as, okay, you will get the x3 as 1.375. 1.375. Okay, this one is the value for x3. Now we are going to replace this value x3 to our function. Okay, to our function. So we take f of x3. Okay, f of x3 can be written as x3 cube minus x3 minus 1. x3 cube minus x3 minus 1. Okay, now replace x3 here instead of x3. Okay, 1.375 replace here. F of 1.375 is equal to 1.375 cube minus 1.375 minus 1. Okay, this one is our f of 1.375. I just replace the value guys. Okay, x3 as in our function. Okay, so we get the f of 1.375. You can use the calci guys and find out the answer, as already I found the answer. So I'm writing this one again, or this one directly. Okay, which is 0.2246. 0.2246. Okay, and which we say that which is it seems like this one is a positive value. Okay, so this one is the positive value. So if this one is a positive value, so we have to search another negative value for 1.25 and 1.50. Okay, now see that 1.25 is a negative value, 1.50 is a positive value, so we cannot consider 1.50. So we consider only 1.25, which is the minus 0.2968, which is a negative value. Okay, okay, so we consider f of 1.25. Okay, f of 1.25, which gives us the value minus 0.2968. 2968. Okay, which is smaller than 0, which is a negative value. Okay, now see that here we can say that one root gives us the value positive, another one gives us the value negative. Obviously the solution lies between 1.375 and 1.25. Okay, so I got the contracted interval again, 1.25 and 1.375. the root lies between these two interval. Okay, yes, so we have to repeat similar process again to the next iteration. Okay, so let's continue to the next iteration. Okay, consider that we have next value x4 as the middle value. So we can find x4 as 1.25 plus 1.375. Okay, 1.25 plus 1.375, divided by 2. Okay, 1.25 is this one, guys. Okay, so if you add, you will get the x4 as 1.3125. 1.3125. Okay, this one is the value for x4. so f of x4 means 1.3125 as a put the value 1.3125 cube. 1.3125 cube minus 1.3125 minus 1. Okay, so find out this value. So at the end we will get the value minus 0.0515. Okay, minus 0.05, okay, 15, which is the negative value, guys. Okay, this one is a negative. So root lies between positive and negative. This one is a negative, this one is a positive. So root lies between 1.375 and 1.3125. Okay, this implies root lies between 1.3125 and 1. This one is negative. Okay, 1.375. okay, root lies between these two values, guys. Okay, so between these two values we have root here. Okay, now we have to find out. Now see that we have really close values. Okay, 1.331 and 1.37. this is very close value. So if we add these two value and divide by 2, directly you will get the answer, guys. Okay, so we take last of the iteration x5 as a 1.3125 plus 1.375 divided by 2. Okay, add all of them, guys. You will get the value x5 as, okay, you will get the value for x5 as 1.3437. 1.3437. okay, this one is our required root, guys. Okay, so if you want to verify this one, put this one into our f of x, you will get the required f of x as a 0. Okay, so this one is our required root for our given solution. I hope that you all have understood, guys, root for this solution. Okay, equation. It's not that difficult, guys. It is one of the easy. Need to extend the iteration until and unless we get our required f of x as a 0, or you can judge the value. Whenever we have close value, we can easily say that this one is the required root for our function. Okay, so I hope you all have understood, guys. It is one of the easy question from bisection method. Okay, so I hope you all have understood everything here. So if you like this video, guys, let me know in my comment section. If you have any doubt, difficulty, comment me in my comment box. I will come up with the similar videos, guys. Okay, so that's it here for my today's lecture, guys. So thank you everyone. Thank you for my today's lecture.